So this is what we have so far. It's looking good. Now let's move on to actually make these particles looking more like sparks. I'm going to turn off the display flag for the Thunderbolts and also for Iron Man. Notice that even though Iron Man isn't has the display flag off, we're still seeing the part of Iron Man that we were using as a static object for simulating the collisions. And let's have a look at the sparks. Now, the reason why that's happening is because on this tab, Object Merge, is where you're gonna define what's coming out of the DOP network. Right now, you're saying everything. By default, this is the setup by default, so it's gonna bring out everything, including, in this case, the pop object, which has the particles information, and also the static object, which we don't really care about. So if we dive inside, you'll see that we have a pop object and a static object. We are only interested on this information. So we can just type here on the object pop object, and it's going to bring everything related just to the particles, and we won't have any geometry being displayed. Now, the other thing that you should keep in mind is the information that's coming out. If you middle mouse button, you'll see we have a lot of attributes that we probably not going to be using. So it's a good idea for you to clean up. It's a good habit to have because imagine that you're caching this effect, and if you don't need the attributes, then you can save a lot of disk space by eliminating the attributes that you know you're not going to be needing. So what we're going to do is create an attribute delete. And here on the points, we'll say we'll delete everything except velocity, the ID, and the color. Everything else we can get rid of. So we don't have primitives or vertices, but just in case. So this cleans up. It makes things simpler. Notice that we have the different point groups based on the stream, and we have those attributes that we preserved. Now the next thing is we'll want to add a trail. We want these particles to leave a trail as they fall, so that we don't just have kind of spheres. The velocity is going to give us some nice motion blur, but usually we want to take care ourselves of some kind of a dragged shape, more of a teardrop shape rather than just a shiny point. And we can do that by using a trail SOP. We've used the trail SOP before for computing velocity, but we can use the trail operator for leaving a trail based on time. And if we increase the trail length, this is going to increase the trail that's being left by the particles. And as you can see, it goes back this trail increment. Now it's going back one frame for each one of these particles. If we increase the trail, we're going to get a longer trail. Instead of having just one frame, the previous frame as well, a trail of one frame will have a trail of 4 frames. And you can make this very high. It'll be easier for us to understand how this is working if we actually connect the dots. You do have some options here of connecting the dots as mesh, as polygons, but this is not what we want. We really just want to connect the trail based on each particle ID. Okay, so it's not going to be randomly connecting points. We want it to connect the points based on the particle ID. So in that case, it will always know, using the ID, the trail will always know that which particle belongs to that particle's trail. So we'll use an add SOP, and the add is very versatile, and one of the things it does is here on polygons, we can add a polyline by group, and we can use an attribute to do that, and the attribute is going to be the ID, and this will give us the trail of the sparks. It'll just make it easier for us to actually see what's happening with the trail. Okay, so we can have shorter trails and longer trails. Right now, the increment that we're using is 1 frame. If we try to go to 0.5, for instance, this is going to go insane because it doesn't really have that information. It doesn't know what's happening in between frames. We don't have that information. Coming out of the POP network, we only have information based on what's cached, and we're only caching each frame. So it doesn't know what's happening between with an increment of half a frame. The way to solve that is by using another SOP called time blend. And time blend has the ability to do exactly that. Calculate the space between, or that's what's happening between frames. That's exactly what it does. So let's go to time blend. And now, as you can see, it already solved the problem. So if we disable this, it goes crazy. If we add this, we actually have half a frame of a trail. And we can have less, we can have more, but now we have those intermediate values happening. Time blend is going to interpolate between frames, and it can even use velocity when interpolating position, and that's something that we want to activate as well. Okay, so now we can actually control the length of the length of the trail. We can use, let's say, 0.2, and we can do increments of 0.2, and we'll get something like this. Okay, we get this type of organization. So we'll leave it at 0.2 for now, with trail length of 3. So 3 elements, 3 points in time. And let me turn this off. Now, the next step is going to be for us to resample these splines. We'll apply a resample, and there are 2 reasons for us to do that. If you go to the trail and turning the points back on, you notice that there's a slight angle between some of these. If we increase the length, we'll get more of an angle, or if we increase the increment, we'll get an angle. Say 0.3 with a trail length of 4, we get an angle. And we get with resample, we can actually kind of smooth these out. So let's say the length, we want them a length of 0.01, we get a bit more points, and you can treat polygons as subdivision curves, and that's gonna smooth out the shape. Okay, so now we have kind of a curve. We can also kind of do 0.02. This will probably be enough, but let's leave it at 0.01. These are just too long. Of course, it's a matter of personal preference. You can adjust this as you like, but I'm gonna put this smaller, 0.2, and here maybe 3, and this is probably gonna be enough. Now, the next step is gonna be for us to actually give it some thickness. We've done similar operations before, but we're gonna apply them for each one of these. And to have that kind of teardrop shape where we have thicker part at the tip, and on the other extremity we'll have thinner shape, we'll be using from the resample the curve view attribute that it can generate automatically for each one of these lines. And using the curve view attribute, we'll be able to map the thickness to the points of each line.